Hey guys, I hope you had a great weekend. I appreciate you checking in. Today's going to be pretty quick. Um, the topic that we are going to discuss is an old topic. It is distance and midpoint. You will notice that all of it, well, 95% of it is all from last year. You will have only two assignments this week. It is to cover distance and midpoint. We will take Wednesday to go over any questions you have. And then hopefully by Friday, if not Sunday, you'll have all the work in. And we'll start the next section on Monday. So distance midpoint is this week, and we will move into the next topic most likely Monday of next week. So with that being said, again, it's going to be a quick day. Just want to kind of review what we're looking at with distance and midpoint. Remember from geometry that our distance formula was the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We wanted to make sure that even if it was x1 minus x2, y1 minus y2, we still had order. That was our distance formula for two endpoints. X1, Y1, and X2, Y2. Now, hi, I got 90 here today. That's awesome. We did have midpoint, and again, that was with two endpoints, and that was an ordered pair. Again, for whatever reason, that was always the toughest to remember that it was an ordered pair, and it was just our average of our coordinates. So these two went with two endpoints. And the idea is that it's on our coordinate plane. Now we are going to look at briefly at the end of today. You'll notice the formula is not going to be any different. On our Cartesian plane, and that's just the fancy way of saying x-axis and y-axis, that's where we end up with our two endpoints. But we do have that instance in algebra and in geometry where we have three dimensions. And so that's when that third ordered pair would come in. And I know at the beginning of the year when we talked about solving systems with three variables, x, y, and z, we had that three variable or three parts of our plane. And we looked at a plane that no longer and it was kind of this three-dimensional idea where we had our x, y, and z plane, and a point would like float up here. I'm trying to think how to show it to you guys over the hover cam. But you'd have a plane going horizontally, you'd have a plane going vertically, but it's this idea that you have your x, y this way, but now we have this third plane standing straight up, and we have a point kind of floating out here. So it kind of has this 3-dimension idea. So it's horizontal, vertical, and then it gives it height up here. So remember from first semester, that's what we were talking about, this random point that would have our x, y, and z coordinate. So there is a distance formula for this idea that we do have 3 variables for 3 dimensions. And the only thing different is we add on the z part. That's it. Same formula, just z2 minus z1 squared. Now we did have, and it's not a part of this, but if we are talking about 3 dimensions, and I don't think you'll see it in this section, but if we are talking about 3 dimensions, we did have something in our triangles, kind of like an extension. Don't forget that in our centroid, in our triangles, that centroid was our balance point. And that was where all these medians would intersect at the same point. And that centroid then had 3 coordinates. So again, it's not a 3-dimensional shape, but it did have 3 coordinates. And our centroid then had something where it was x1 plus x2 plus x3. So it wasn't that we had 3 variables, it was just that we had, and I don't want, when we're talking about midpoint, I don't want our centroid formula to get misunderstood with how our distance formula has 3 dimensions, so it'll have 3 different instances to talk about the distance from the same or from each of these axes, where this one is 3 different ordered pairs, but they're all just x's and y's. So we have a distance with 2 endpoints, a midpoint with 2 endpoints. We have distance, where we're going to talk about those 3 variables that we'll work in. Centroid isn't the same. We are not talking about x, y, and z, but we are talking about 3 different endpoints that if we did calculate. So don't get this one mixed up with this if you're starting to think about stuff from last year. So these are the 3 that we're going to worry about today. These 2, pretty straightforward. That one you're going to find not much different. So let's go ahead and just look at one example in review for distance and midpoint. One example with our 3 variable, and I do believe that should be good for the majority of us, at least for today. So for example, okay, obviously this looks very much like a geometry lesson. That's pretty much what we're looking at right now. So I'll give you a second to copy that guy down. All right, so what we are looking to do is, again, just fill in our formula. So if we're looking at our distance, I'm going to go ahead with 7 minus 2. And because I started with 7, I'm going to go back to 12 minus 5 and square that. We end up with 5 squared plus 7 squared. And we end up with the square root of 74. And I would venture to guess that that is going to be it. In order to rationalize, all I did was plug in 74 into my calculator. I wanted to see what its factors were. 74 divided by 2 is 37. So the fact that we have two prime number factors, our answer, we're going to leave like this. So remember, we want exact value. So the distance between our two endpoints is just radical 74. Now, obviously, if this was a real life question, what you are going to have to do then is answer the question according to how they ask it. For instance, approximately how many miles or approximately how many feet, you'd obviously have to take the square root of 74. If we then did the midpoint, 7 plus 2 divided by 2, 12 plus 5 divided by 2, we end up with 9 divided by 2, 17 divided by 2, and we have a midpoint of 4.5 and 8.5. Again, that's it. That's all we're looking at. I don't foresee this causing many issues. We did tons of this last year, so I just wanted to do that in review. So the only other one that I do want to take a look at Okay. So just in case we have a situation where we're going to have negatives, I also involved the negatives here. So we're going to find the distance between point A, which is 1, 3, and 5, and point B, -2, 3, and -4. So for our distance formula, again, the only difference is we end up adding on the z's in this. I'm going to take -2 minus 1, square that. Back to 3 minus 3, square that. And -4 minus 5, square that. So again, the only differences are z-squares. And in each one, I started down here at B, -1, 3, minus 3, -4, minus 5. And we end up with -3 squared plus 0 squared plus -9 squared. 9 plus 0 plus 81 gives us the square root of 90. And hopefully, we can all see what our distance is between those 2 points, because when we simplify, I can see that this is going to be 9 times 10. We know 10 we can't take the square root of, but we know 9 we can. So our distance would be 3 radical 10. And again, for now, that's all we're worried about. All right. With that being said, I figured you guys have, Mr. Colahan and I discussed how to start this week. Right now, that's where we're going to be today. Let me know in the chat, does that seem pretty straightforward, pretty easy for today? All right. Then that is all for today. I want to make sure that if for some reason I have to, there's anything that you have forgotten or that you need from me, make sure you email anything, any requests or any questions before the end of the day. I need to make sure all of the grades are in and loaded and approved by tomorrow so that Mrs. Adkins can run all the grades on Wednesday. So any last ditch effort, make sure that you let me know. Otherwise, grades will be finalized at the end of the day today so that they aren't waiting on me. So with that being said, check Google Classroom for any updates. I will be loading the work for the week here shortly. But that's all for today. Thank you so much, everyone. I hope you have a great rest of your Monday.